Hello grade 12s and welcome to my channel once again. On today's video we are starting a new chapter. I'll be going through calculus with you guys. We will be unfolding all the sections under calculus, starting from first principles, going into differentiating, doing curves, your cubic curves or your cubic graphs, and we will wrap it up with your optimization of calculus. But for this lesson specifically, I want us to focus only on first principles, and then you do have to tune in for the next videos because I'll just be unfolding and going through the other sections. So let us start. So in calculus, guys, what we do is we just work with gradients. So because we are going to do a lot of deriving, a lot of differentiating, every time when you find yourself deriving or differentiating an equation, just know that that derivative that you get represents what? It represents a gradient. So we know from the previous grades, especially if we take it a little back to your geometry, we do work with a gradient, and we know with the gradient you can work the gradient of a straight line that has any 2 points. You can work the gradient if you have the coordinates, and the gradient would be y2 minus y1 over x2 minus x1. So that is when you have 2 points. But now when we shift it to calculus, we start to work with the gradient only at 1 point, just at a single point, meaning the moment you derive that derivative, you can use it to find the gradient at a single point. It represents a gradient at a single point. So I'm just gonna make just a little bit of an illustration. I'm not going to get deeper into the gradient at a single point graphically, but if you think about, let's say, your cubic graph, if you think about a cubic graph, and then on your cubic graph, we know you can have a tangent. Remember, a tangent from geometry is just the line that's going to touch the graph at 1 point, just at that point. That is your tangent. Then you can have a secant. A secant, it's a line that can touch your graph twice. So it crosses the graph, meaning that over there and that over there. So it touches the graph more than once. That is your secant. And now it means, yes, you can calculate the gradient of the secant. However, if we now think about these 2 points getting closer and closer and closer and closer, meaning the distance between the 2 points, let's say the distance is h, if it's getting closer and closer and closer, the points end up forming just a single point there that will now look like a tangent. It will become a tangent. So I'm just gonna leave it here for now. I want us now to jump into okay, I'm just gonna leave it here. I want us to jump now into deriving using first principles. So when we say we derive, let me not use the word derive, let us use differentiating. To differentiate, because they normally use differentiate with principle. Differentiate using first principles. So it means we are going to look at how you can differentiate using this first principle, and you will only differentiate using first principles if they specify and say differentiate using first principle. Other than that, you don't, only when they specify. Okay, so when we do now differentiating using first principle, we are saying if you have f at x, if you have your f at x, which represents a certain equation, if you differentiate it, it becomes f prime x. okay, f prime x. And then now we are saying, okay, this f prime x is it's when you have differentiated, and it is equals to the limit as h tends into 0, or as h becomes 0. What does this mean? Remember when I talked about these 2 points moving closer and closer to each other until they are now a single point, or and then now they can be a tangent. So this limit as h tends into 0, this is what it means. As the distance between the 2 points gets smaller and smaller until it is at 0. When it is at 0, it means we have a tangent, and we say the equation would be f at x plus h minus f at x divided by the height. This is the equation for, or this is the formula for calculating or for differentiating using first principles. Every time when they say first principle, guys, you are going to use f prime x. It's equals to the limit as h tends to be 0, f at x plus h minus f at x over h. I'm going to explain this part now. The f at x plus h minus f at x, it's equals to h. So what it means is that if we say f at x plus h, depending on what equation they would have given you, on that equation, wherever you see x, you're going to replace it with x plus h. And then your f at x, it's just the original equation that they've given you. You just plug it as it is. Okay, the original equation. So that is your f at x and your minus f at x plus h. So I'm going to jump onto our first example on differentiating using first principles. So we have f at x equals to 3x squared, and then the question says, I'm just going to erase that, differentiate using first principles. Differentiate using first principles. So we know that, okay, from first principles we know that f prime x, it's equals to the limit as h becomes 0, where you have f at x plus h minus f at x divided by h. So the first step, we are going to say, okay, what is our f at x plus h? F at x plus h. So it means you take that original equation. Remember we had said wherever you see x on the original equation, you put x plus h. So the original equation is 3x, so it's going to be 3 open bracket. So the original equation, I meant, it's 3x squared, so it's 3 in the bracket x plus h squared, and we need to now simplify it. So x plus h is 2 brackets, so we have to FOIL them. X plus h, x times x, so I'll still keep the 3 there. X times x is x squared, x times h is xh, h times x, it's also xh, h times h is h squared. And then now we have 3x squared plus 2, so xh plus xh is 2xh plus h squared. Then now we are going to remove the bracket, meaning we distribute the 3 inside. 3 times x squared is x squared, 3 times 2xh is 6xh, and then 3 times h squared is 3h squared. So that is our f at x plus h. And then remember, it's f at x plus h minus f at x. So it means our f at x, it's just the original equation as it is, because I had stated there that your f at x is the original equation. So it's going to be 3x squared. So we have 3x squared. Now we are going to plug your f at x plus h and f at x on that f prime x equals to the limit as h tends to be 0, and then our f at x plus h, it's going to be 3x squared plus 6xh plus 3h squared. So we have managed to plug in the f at x plus h, then minus, and then most importantly, every time when you put this minus, this one, after that minus you must always put a bracket, open bracket, 3x squared. Remember our main formula, it has an h, it is divided by h. I dropped something there, so this is 6xh. Sorry guys, I made a mistake. So now we will look for like terms. So as you work this expression, you need to still keep the limit as h tends to be 0. You don't omit it. You will carry it until just the last step before you substitute the 0. But you will see as we move. So 3x squared and negative 3x squared are like terms, so they will give us 0. So we'll be left with 6xh plus h squared over h, and then we have a h there and then h, so we can take it out as a common factor. I still carry my limit as h tends to be 0, and then I will take out my h as a common factor. So h, and then if I take out h on 6xh, I'll be left with just 6x. Then if I take out h on h squared, I'll be left with h all divided by h. If you did watch the previous video that I posted on how to tell when to cancel, you will know that that h and that h will cancel, because between the h and the bracket there's a multiplication. So when there is a multiplication, you can cancel out. Now it means our limit as h tends to be 0 is 6x plus h. And then now, because we are saying as h tends to be 0, it means we are making our h 0, then the final answer is going to be 6x. So your f prime x is 6x, and that is our final answer. I hope it makes sense, guys. I hope you're following along, because this is always the first question under that section on your question paper under calculus. They will always ask you to differentiate using first principles, ranging from 5 marks, can be more, it can be less, but it is actually a point where you can grab all the marks as long as you know your algebra and as long as you know how to apply these principles. We will now jump on to our next example. So for our next example, we have f at x. So I'm just gonna write example 2. Let me just use my red pen. So we have f at x equals to so we have 2x squared plus 7x minus 5, and the question still says differentiate using first principles. So the moment we say first principles, you know you're going to use first principles. So differentiate using first principles. Remember, your f prime x is f at nope, we missed something there. It's the limit as h tends to be 0, where we have f at x plus h minus f at x divided by h. So the first step, we are going to get our f at x plus h. Remember, f at x plus h, it means on your original equation, wherever you see x, you put x plus h. So we have 2, there's an x there, so we replace it with x plus h squared plus 7 there's an x there, so that's going to be x plus h. Then we have a negative 5. So now we need to do some algebra there. 2x plus h squared. I'm not going to expand it again. Believe me guys, if you've done this 3 times, 4 times already, you would be knowing that you have x squared plus 2xh plus h squared. Because you are doing it multiple times, you automatically absorb it in your brain, which is quite good. Plus, then the 7 times x is 7x, 7 times h is 7 height, no, not height but h, negative 5. And then let us distribute that. We have 2x squared plus 4xh plus 2h squared. So I'm distributing the 2 into the brackets, plus 7x plus 7h minus 5. Do we have any like terms? No, we don't have any like terms, so we keep it at that. And then our f at x is the original, so it's going to be 2x squared plus 7x minus 5. Okay, it's quite a long one. Let us now take it on to our limit formula. F at x is the limit as h tends to be 0. Then my f at x plus h, okay, let me write it. F at x plus h minus f at x equals to h. And my f at x plus h, I'm just gonna start it over there because I need as much space as I can possibly get. So we have 2x squared plus 4xh plus 2h squared plus 7x plus 7h minus 5 minus, this is that red minus over there. And remember, I had said every time when you find yourself putting that minus, you put a bracket after that minus. Then you have 2x squared plus 7x minus 5. I hope you're still following, guys. All divided by our h. So now let us distribute that negative, remove the bracket. So we have the limit as h tends to be 0. We have 2x squared plus 4xh plus 2h squared plus 7x plus 7h minus 5. Negative times 2x, it's negative times 2x squared, it's negative 2x squared. Negative times 7x, it's negative, sorry, that there must be an exponent 2 there. I'm just gonna bring it down here. 2x squared. Negative times 7x, it's negative 7x. Negative times negative 5 is positive 5. You see the importance of that minus over there. Please don't forget to put a bracket, guys. I beg you, because if you don't put a bracket, it's going to affect your final answer. Please, 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 many times, 1,000 times, put a bracket after that negative. If you missed the part where I explained that negative, it is the negative between f at x plus h and f at x. That negative there. Please, 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 please. We need a bracket after it. Still divided by the height. So now we can try and look for our like terms. 2x squared and negative 2x squared. So these two are going out. 4xh, we don't have any 4xh. 2h squared, we don't have any 2h squared. Let's check. No, we don't. 7x, we do have a like term for 7x. It's the minus 7x. So these two are going away because positive 7x minus 7x is 0. 7h, we don't have any 7h, any like term, but a negative 5, it goes with the positive 5. So they also go away. You see, now we are trying to eliminate because we want it as simple as possible. So now we have the limit as h tends into 0, and then we are left with 4xh plus 2h squared plus 7h. Simple and simplified over h. You know, at this point, after you cancel out, for you to see that you're on the right track, everything there must have a h so that you can take it out as a common factor and then you cancel. But if you don't have something like that, it means you need to go back and check. Firstly, check if you put a bracket there, because this bracket, it breaks my heart, because if you don't put a bracket, it's going to give you a wrong answer. Nothing is going to cancel out. Okay, so I'm going to always emphasize on that bracket. So now at this point we can take out a common factor of h. So if we take out h, it means there I'll be left with just 4x, there I'll be left with just 2 and 1h because 1 is out, then there I just have 7 divided by h. Then now you can nicely cancel out your h's and you are left with the limit as h tends into 0. Remember guys, the limit as h tends into 0, you are going to carry it until just the second last step, the last step before, okay, how am I supposed to put it? Just before you substitute your 0, the step above the one where you substitute your 0. So it means I have 4x plus 2h plus 7, and then now I'm substituting my 0, I'm making my h 0, meaning it's going to be 4x, and then there I have 2 times the 0 there because the h will be 0. It's 0 plus 7. So my final answer is 4x plus 7. I hope you guys are still following. I hope you will remember to put a bracket after that negative. And guys, you would see, I know some of you might be doing this one differently. For example, the f at x plus h and the f at x, you might be doing it already there. It's still fine as long as it doesn't complicate things, because this one will just make things easier for you, because when you go to the bracket, I mean to the fraction, you already have things being simplified. Okay, we are going to do one more, and this one is slightly different because it is a fraction. Okay, this is the last one under this section. So example number 3, we have f at x equals to 1 over x. So now we have a fraction, and the question still says differentiate, I hope my handwriting is readable, differentiate using first principles. But it is readable guys, it is using first principles. The moment they say first principle, you already know, my friend, you already know you are going to use first principle. And I'm also going to repeat, if they say differentiate and they don't say using first principles, you don't use first principles. Or because we are still going to do the next part of differentiating on the next part of this video, where we differentiate using the derivative. With that one is the shorter method. So the reason I'm bringing this is because when they say differentiate using first principles, if you use derivative, the short method, it means you're losing marks. When they say first principles, please use first principles. Okay, so let us get to this one. So starting with our f at x plus h, our f at x plus h is going to be 1 over x plus h, and then our f at x, it's still 1 over x. Now putting in our formula, f prime x is the limit as h tends to be 0. Limit as h tends to be 0 should be your best friend when you do these questions, because you have to put it. F at x plus h minus f at x divided by h. Our f at x plus h as limit tends to be 0. We have 1 over x plus h minus bracket 1 over x divided by h. So now, yeah, we have two fractions. Now we are working with fractions, meaning we are now going to use the LCD method. I know you guys do know how to choose your LCD, because I've shown you on that previous video, the video before this one. If you haven't watched that video, guys, please run. Don't walk, run to that video, because in grade 12 you do need to know, you must know how to choose an LCD, not only for calculus, for geometry, for trigonometry. When you prove trigonometric problems, you need to know when to choose an LCD and how to choose an LCD. Very, 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 very important. Okay, so guys, please do make sure you know how to choose your LCD, but because I'm kind, I'm still going to show you how to choose an LCD. So we have the limit as h tends to 0. So we have x plus h and x. Because our denominators are two quite different things, it means they are both LCD. So it means I'm going to just squeeze it here. Our LCD is going to be x plus h and x. Therefore, it means I'm going to divide everything. So remember, if you have chosen an LCD, you now put everything under the LCD, x plus h and x. And then now you check the one there, because it has a denominator of x plus h. It has, okay, I'm not using colors, but because it has x plus h, it means I just multiplied with x. So that's 1 times x minus, and then that one over there, the 1 has a denominator of x. It doesn't have the x plus h, so I'm going to say minus bracket, the importance of putting a bracket, x plus h. Guys, in maths, when you're solving problems, every time when there's a minus, whatever comes after the minus must be in a bracket, especially if you're going to, because you're going to multiply that minus in the bracket, and it will end up changing what is inside of the bracket. Divide by h. So as the limit as h tends to be 0, so it means I have x minus h over x plus h x. So I also did mention that you do not have to quickly FOIL out or remove those brackets there. Keep them, because sometimes you need them as they are. And then now we have the limit as h tends to be 0. X minus x is 0, so we have only negative h over x plus h, this side, and the x. And then remember, if you are dividing a fraction with a fraction or a fraction with a number, you can change the division to a multiplication, and that becomes 1 over h. So when you change that to a multiplication, the h becomes a reciprocal. If it was h over 1, it becomes 1 over h. We have the limit as h tends to be 0. The h and the h there cancels. Then we are left with negative 1 x plus h x. And then remember, we had said we want to now substitute the 0. So I'm going to substitute the 0 there on the h. So I'm going to have negative 1 over x plus 0 is just x, and then times the x, which is negative 1 over x squared, and that would be our final answer. So our final answer is negative 1 over x squared. Okay, so I will stop here for today, guys. I hope from this video you would never miss any single mark from deriving or differentiating from first principles. Please be very, very cautious when you substitute, when you multiply out your brackets. When you have a negative, put a bracket after the negative, so that we have all the marks. I mean, 5 marks, it's quite a lot, so we do need all the marks. Thank you so much for watching. Please do tune in for part 2, and for our part 2 we will be looking at the rules of deriving. And if you haven't subscribed, this is the right time for you to subscribe, and please do like the video, do comment, interact with me, tell me guys what you would like for me to cover or where you need clarity. Thank you so much guys. Bye bye.